About the dishes, the parties, the dishes, the parties, the providers, and so on. And this year I'm going to try a different approach. So I'm going to try to convince you to visit my country, doing a quick summary about the history of Spain. The history of Spain in only 1 minute. Is okay for you?
Okay.
Well, 2,000 years ago, Spain was a Roman country. In fact, we have some of the best Roman emperors born in Spain, like Trajano and Adriano. And if you visit Spain, you can discover in the middle of the city a lot of Roman monuments like this in Segovia or this theater in Merida. All country is full of these Roman monuments. Centuries after, Spain was a medieval country, and if you visit the country, you will find a lot of castles. Actually, there are hundreds and hundreds of castles, and you can visit all of them, even you can buy it, if you have enough money, because some of them are for sale. It's true, it's not a joke. After that, Spain was an Arabic country, 7 centuries being an Arabic country. And if you visit Spain, you will discover that there are a lot of mezquitas around the country with beautiful monuments in all the country. And after that, Spain was an empire, probably you know it. And like Spain was an empire, all Greek artists wanted to work for the empire. So in Spain there are a lot of museums with great artists, paintings like this. So, are you going to visit Spain, please? Okay. Well, we are not prepared anymore to prove now. So let's talk about FOCA. How many of you know FOCA? How many of you love FOCA? Yeah. Well, today we are going to talk about another FOCA. It's not the FOCA that you probably know. It's a new FOCA, and it's a FOCA based on hybrid networks. The idea of this tool is that probably most of the users, anytime in their life, have tried a very dangerous command in their operating system, which is the IPv6. Have you ever tried this command? It's very dangerous and very difficult to understand this command because, well, as you can see, it's in Spanish, because Spanish is better. And as you can see, there is a special magic in the result that you can see, because if you ask to any user that type this command, what is the IP address? All users are going to say 192.168.1 and so on. Nobody can see the IP address on top of the list. Have you seen that IP address? The big one? Yeah? Most of the users when realize that there is something on top of the IP address, do something like this. Well, the truth is that in all Windows operating system, IPv6 is working by default. It's turning on. So if you go to test your network configuration, you're going to realize that IPv6 is turning on, and by default is configured like this. It's in Spanish, you know what? That means automatic configuration. That means that IPv6 is waiting to be configured to run on the machine, but it is working. And if you test the routing table, you can realize that you have all the routing table for IPv6 installed in your computer, and even one of the most dangerous commands, the ping. Ping is working. So I'm going to do a demo, an easy one. I got 2 machines. One of those is this blue. The blue is the server. And as you can see, we have an IPv6 address and an IPv4. The IPv6 is FA80 whatever, and the IPv4 is 192.168.10.1. And if we go to the client, to the other machine, which is the red one, and try to do a ping to the IPv4, 192.168.10.1, it is working. If we try to discover what is the name of this server, we got that the name is shared. If we try the IPv6 address, of course, it is working as well. And if we do something like ping the name, then magic occurs. Because by default, Windows tries to connect using IPv6. But probably all of you are aware of this. Is this true? Yeah. And you are taking care of IPv6 attacks, for sure. Well, this said, the idea of IPv6 is that in Windows machine, both protocols are working at the same time. Depending on the configuration of your network, the machine is going to use IPv4 or IPv6. If you have an IPv4 network fully configured with a domain controller, with the DNS, and all the computers are in the DNS, and all of them are working with the IPv4, then the network is going to work as an IPv4 network by default. But if you are in a local network connected with all the computers from different parts, they are not in the same DNS, they are not in the same domain controller, then IPv6 will appear a lot of time. This is due because in Windows Vista, Microsoft added this protocol, Local Link Manager, which is a protocol that tries to discover what is the IP address of a computer in the network. It is working only in the local network, in the local segment, and as you can see, it's trying to discover the IP address of the computer for any protocol. So it's trying to query the DNS as an ARP record, it's trying to query the DNS as an IPv6 record, it's trying to do a broadcasting discovery. Sorry. Whatever. In the end, when Local Link Manager discovered the IP address of the destination server, if it's possible to connect using IPv6, then it's going to connect using IPv6. Once we have the IP address, we need the physical address. To discover the physical address in IPv4, we are using ARP, but ARP is not working in IPv6 anymore. So if you have a security solution to detect man-in-the-middle attacks with ARP, is very good for IPv4, but not for IPv6. Because in IPv6, we are using a different protocol, which is neighbor discovery protocol, based in two different messages, which are neighbor solicitation and neighbor adaptation. In the end, neighbor solicitation and neighbor adaptation are working at the same way that ARP, but it's not ARP. That's important. We got a table also in which we connect the IPv6 address with the physical address. In IPv4 is the ARP table, in IPv6 is the neighbor table, and it's in your computer. You can query the table using that command. This said, how it works is like this. Someone is trying to discover the physical address of an IPv6 computer, then send a messages to FF2, which is a multicast address, querying for the IPv6 address in which is interested. In this case, this one. The computer with this IPv6 address, in this case, this one is going to answer with the physical address. It's very easy to understand. It's the same than that. That means perform a man-in-the-middle attack in this environment is very easy. We only need to send two packets like ARP. It's very easy. The idea is that we need to send a packet to one of the computers spoofing the IPv6 address of the other victim, and then do the same with the other machine. Only two packets, and we have the man in the middle, like in ARP. So let's do a very easy demo, a quick demo. It's level 1. Very easy to do and very easy to understand in this environment. But before doing it, you have to take into account that we are Spaniards, so we are lazy. We need tools for work. So we created the input FOCA. Okay? In this demo, we have 3 machines. The blue one is a server. The red one is the victim, is the client, and the black one is the input FOCA. So we only need to do something like open WhatsApp, open Evil FOCA, yes, then Evil FOCA discovered the network, just drag, click, and that's it. Okay? So, if we go to WireSat in this machine, and we start to capture information, capture interfaces, internal. And we do something very easy, go to the client, and from the client, do // server, connect to the server, open a document with my password, and then we go to the FOCA, to the old FOCA. We only need to do follow TCP string, and that's it. We got all the information, and we can use the file to search for the password and hit it. Okay? Well, this is very easy. It's level 1. I'm going to stop the server. I don't need the server anymore. And now we are going to get into the level 2. The idea of level 2 is, okay, we got the IPv6 in the network, but I want to be a man in the middle when the victim connects to the internet, which is working in IPv4, and that's the challenge. Well, this is the demo that I did, just in case that it didn't work. And the second demo is on Slack. Yesterday there was a talk talking about this. We released this tool in March. It's public, this tool in March with this attack, and the idea is quite simple. In IPv6, there are a lot of computers, there are big IP addresses, and it would be impossible for a sysadmin to manage all the roles on the network. I have 1,000 computers and 300 routers. It would be a mess. So the idea from the beginning is that you don't have to worry about the default gateway, because we are going to create a protocol to configure the gateway on the computers. That protocol is Slack. That means stateless address auto configuration. And the idea is quite simple. When a computer with IPv6 needs to connect to the internet, asks for a router with a package called router solicitation, and if there is in a router in the network, answer with the network advertisement saying, hey, here a router, here a friend. After that, the computer configures automatically an IPv6 network that has connectivity with the router, and configure the router as the default gateway. Very easy to do, very easy to understand. That protocol only configures the default gateway, but not the DNS. You need to configure the DNS. Not always. You can use also the route DHCP to configure the DNS, but it's not completely necessary, because in Windows machines there is a special protocol, which is the DNS auto discovery. So if your computer doesn't have any DNS configured, by default use these 3 IP address. That means that if someone configures that IP address in your network, it will be the DNS in your network. You need to take care of this IP address. So to do the attack is very easy, because all web browsers are ready to work with IPv6. Well, this is Mozilla, which is ready for IPv6. In Google Chrome, it's deactivated. IPv6 is deactivated by default. So if the guy is using Google Chrome, you cannot do this attack. You can do the next one. Don't worry. And there are several situations in which IPv6 attacks are not working very well, because Windows have a very special behavior. If you have IPv4 and IPv6 fully configured, I mean with the DNS and the default gateway, then Windows use the DNS configured in the IPv4 protocol. It makes sense, because in the end, DNS is supposed to be only one copy in the whole internet. So it doesn't matter I'm connected to the DNS using IPv4 or IPv6. And in Windows, they choose to use IPv4 protocol to connect to the DNS. If you don't have IPv4 fully configured, for instance, if the DHCP is failing to give you to the default gateway or to the DNS, then if we configure IPv6, the computer is going to use the IPv6. But in some cases, by default, it's searching for DNS record of IPv4 address. That means that if we want to create a special man in the middle using IPv6 between the client and the man in the middle, we need to reconstruct the answers to IPv6 records. And of course, if we got IPv6 in IPv4 only a local link, sorry, I'm sick. I don't want it. And if we have IPv6 and IPv4 with local link, then the DNS is going to be used using IPv6 and is going to be querying DNS of IPv6 address. But it's very easy to change the behavior, because if the client asks for a DNS query searching for an IPv4, you can respond with an IPv6 and everything goes well, so don't worry at all. So, what is Evil FOCA doing in this attack? The idea is quite simple. Evil FOCA is going to be this guy, using network address translation 6 to 4 and DNA 6 to 4. The idea is that we are going to configure this connection. We are going to send a Slack attack to configure this as the default gateway. Then it automatically is going to configure the DNS auto-discovery to connect to the internet, and DNS auto-discovery is an IPv6, so we are in the middle. We are going to capture all DNS queries. So when he asks for an IPv4 URL, for instance, www.defcon.org, which is only working IPv4, then that query is going to be sent to the default gateway. We are going to intercept the query. We are going to ask for the real IPv4 on the internet. Then we are going to compare the IPv4 to an IPv6 address and give the IPv6 address to the client, and then the client is going to send the IPv6 query to the default gateway, and we are going to translate the IPv6 to IPv4 and send to the server, and then get the answer, and then but you know, we are Spanish. So let's do the demo. The idea is the first demo, we only need to send 2 packets, one for one victim, one for another. In this example, we need to send a packet to configure the Slack attack, and then we need to do all the translation. And in Evil FOCA, we need to do this. First of all, I'm going to spend a lot of money using my Spanish mobile phone, but I need internet connection. Connect. Okay. Let's see if I have internet connection. Please. Okay, I got internet connection. Then I got the Evil FOCA. I got the Evil FOCA and the victim, and I'm going to do something like open Evil FOCA. I'm going to the victim. I'm going to reset the network adapter, just in case that something was stored from the previous demo. That's all. And all that we need to do is something like go to Evil FOCA and then select Slack, just click here and start. That's all. That's all. It will try to do something like this is the host machine. This is the host machine. If I try to connect to the DNS and search for an IPv6 address for DEFCON.org. As you can see, there is not an IPv6 address for DEFCON.org, and if we go to the victim and we open the web browser, and we search for www.google.com or defcon.org, everything is working. Google and DEFCON, and if we search for the IP address that we are using to connect, it's ping www.defcon.org. It's an IPv6 because we are changing the IPv4 to IPv6, and as you can see, we are browsing the internet. Well, this is the demo, just in case. Level 3. Well, this is level 3. We haven't published this version of FOCA yet, but next week you will have this version available. And the idea is to use the web proxy auto discovery protocol in IPv6. The idea is quite simple. Automatic, by default, all web browsers, Google Chrome, Internet Explorer, Mozilla, Firefox, and so on, by default are searching for a web proxy. A web proxy to configure the internet connection, to discover what is the web proxy. They are searching for a special record in the DNS, which is web proxy auto discovery, WPAD, and then connect to that IP address, and that IP address is supposed to have a server, and the server gives a special file, and that special file gives the IP address of the web server. In this case, of the proxy server. In this case, we are going to use an IPv6 proxy with FOCA. And the idea is that FOCA is going to do everything for you. FOCA configures the DNS answer for WPAD, configures a raw proxy server listening in the IPv6 network, and reroute all traffic between IPv4 and IPv6. So let's do the demo. And then we only need to, I'm going to disable and enable the network interface. I'm going to everything from the beginning. Disable and enable, okay? And then go to FOCA, open FOCA, and then we select W web proxy auto discovery and click, and that's it. And right now we have here that we are working the man-in-the-middle attack for web proxy auto discovery. Then we need to wait until web proxy auto discovery query appears. Let's open Internet Explorer. Let's close Internet Explorer, and let's open it again. And let's see. Okay, now the proxy is up, and the client has requested the file. So if everything is okay, we can do something like google.com. Let's see if the internet is working very well. Google, internet, please be a good guy. Google. Here it is. Okay? Now, we are doing the man-in-the-middle again using different protocols, but we wanted more. So this was the demo. The demo was that the client sends, the victim sends for WPAD record, then we answer saying, no, it's not an IPv4, it's an IPv6. Then the victim asks again about the WPAD record, but in this case searching for an IPv6 address. We confirm, yes, this is the IPv6 of the web proxy of the discovery server. Then victim connects to the web server requesting the pack file with information about the proxy. We send that information with the IPv6 and the port in which FOCA is listening, and the rest is just capturing the data. Bonus level. What happened with HTTPS connection? Well, there are several options. First one is to do an SSL script. The idea is that we analyze all HTML pages and remove the S of the links. The second one is to use a fake digital certificate and trying to trick the user to click on, okay, I accept this digital certificate. And the third one is to do a bridging HTTPS. That means that FOCA is connecting to the server using HTTPS, and the client is connecting to your FOCA using HTTP. And FOCA is doing SSL strip and bridging HTTPS so far, and we added a special feature that is to remove the HTTPS links in Google results and also the redirect. So let's do the demo. We got here Google, and you can see if we try to open Gmail, we are going to have an HTTP link, but if we search for Facebook, we have the Facebook in Spanish, Facebook in Spanish, and the link is an HTTP. We only need to click on it, and then go to FOCA and open Wireshark. This is open Wireshark. Capture interface, restart, and we got all traffic here, and we only need to go here and test. Oh, come on, this is still loading. Evolve. Where's the password field? FOCA. Where's the enter? No. And we go to the other part and we search for HTTP method, reference method. Equal post. We got the user and password of Facebook. And create well, it's man-in-the-middle attack in IPv6 IPv4 network using IPv6 and Spanish way. And this was the demo. In this tool, we also added other different attacks, just in case, like denial of services in IPv6, man-in-the-middle attacks in IPv4, denial of service in IPv6, DNS hijacking. We're going to add also to inject a JavaScript to create a JavaScript bonded. Remember the last talk. And just a conclusion, IPv6 is in your network, configure it or kill it, and it's not easy to kill it. IPv6, if you have security tools for IPv4, probably they are not working for IPv6. And right now there are a lot of security tools using IPv6, like Opera, which is for scanning using IPv6, Slowdoor is migrated to IPv6. We got several vulnerabilities in IPv6.